is Mr. Hawley's second hour physical science class, and we're going to do a lecture on the rules of significant figures and how to do math with them. Here's my class. Everybody wave. All right, you got the snake man in the middle back there too. All right, you guys, first of all, hands over, good job. First of all, significant figures. They're used in high school science classes, but especially in college. And you know what? Real scientists use these all the time. All right? They show how accurately or precisely a number has been measured. This is very, very important. Scientists have to prove their work to other scientists. Okay? So scientists from one place will go and they will look at the research from another scientist from another place, and they'll replicate their experiments. So they have to know how precisely the numbers have been measured. There are some rules that help us to know how many significant figures are in a measurement when you see something. Like if I say the sun is 1.5 times 10 to the 11th meters away from us, I mean, how accurately was that measured? How precisely do we know that? Okay? This will help us to understand this. First of all, the easy rule, number one, any number that is not a zero is significant. It has been measured. That's what significant means. It has been measured. So look, 189 would have 3. Okay? All right. Now, we've got all these rules about zeros. So the rest of these rules are all about zeros and what to think about them. If you have zeros, all zeros between non-zero numbers, they are significant. They were measured. Think about this. If there's a 1, 8, a 0, and a 9, if the 9 was measured, wasn't the 0 measured also? See, it just ended up being on 0. It could have been a 1. Okay? It could have been a 9. But it was a 0. So it is significant. It was measured. You understand? Okay, now let's talk about placeholders, okay? Let's say somebody didn't do a very good job of measuring something, and we have to show how big the number is, but that it's not very accurately measured. All zeros to the right of a non-zero number, but to the left of a decimal point, are not significant. They're just placeholders. So see all these zeros right here? Those aren't significant. This would have 3 in it. So the 1, 8, and 9 were all measured. The 9 has a little bit of guesswork in it, okay? But all these zeros are just there to hold place. So if you didn't have those 3 zeros there, what would that number be? 189. But with the zeros there, now we know that the number is really, what? 189,000. They have to be there to show how big the number is. You understand? So when I say 1.5 times 10 to the 11th meters, that's how far the sun is. See, if you wrote that out, all those zeros right there would just show that, you know, the distance to the sun is a lot more than 1.5 meters away from us, right? Okay. Now, this is when there's a decimal here, and these zeros are to the left of it. Now, what if the zeros are to the right of it? Okay. All zeros to the left of a non-zero number, but to the right of a decimal point, are not significant. They're placeholders. See, so this is when the number is less than 1. These zeros are just placeholders. So there's still 3 here, 1, 8, 9. Okay? So those zeros just are there just to show how small the number is. You understand? Okay. Now watch this. See how this goes right, left? You see how this goes left, right? Okay. So when zeros are right, left, or left, right, they're not significant. But what if zeros are right, right? Okay? Look at this rule. All zeros to the right of a non-zero number and to the right of a decimal point are significant. Okay, they have been measured. See this right here? If I measure this out all the way to this point, I need to be able to say that that is significant. Maybe it would have come out to a 1, all right? But it happened to land on a 0, so I have to have a rule that shows that it's significant. So this 0 is to the right of a non-zero number, and it's to the right of a decimal point, so it counts as being significant. You understand? Are you catching these rules? It's to the, see the 0 is to the right and to the right. So when a 0 is to the right of a decimal and to the right of a non-zero number, it's significant. Now, what happens if you measure a number right here, like this? If you want to show 64,000 has 4 sig figs in it. If I want to show that that 0 is significant, there's 2 ways of doing that. I can put a bar over it, and that's something we do particularly in physics. Okay, I can put a bar over this. All right? Or if I want to, it's probably better just to write it in scientific notation. Do y'all know how to write scientific notation? Numbers in scientific notation? So I would just move the decimal place to there. That's 4 places over. and then I would just include all the sig figs. So it'd be 6.400. All right, now see, is this 0 to the right and to the right? It is. See, so that's significant. Okay, hey Sabrina, walk over this way. Let's see if you guys know this now. Watch this. Let's do some examples. All right, here we go. How many is in this number? Look at this good filming.
3.
There's 3. Good. They're all non-zero numbers. Good. So there's 3 sig figs. What about this? This 0 between non-zero numbers. So how many are there now?
4.
Good. Good, Laura. Okay, there's 4. Okay, look at this. What are you going to do with these zeros that are to the right and to the left? See, there's an understood decimal point there. So how many are there?
4.
There's 4. 1, 2, 3, 4. These are spacer zeros. Okay? What about this number right here? What if I put a bar over that 0 right there? Okay? So that 0 counts now, right? So if that 0 is significant, then that means that one is too. So there would be 6. Good. Boy, y'all are good. Okay, now, what about these zeros? These zeros are to the right and to the left. So how many are there?
2.
There's 2. That's right. We're getting some excellent filming here, by the way. All right, how about this? Look at that 0. That 0 is to the right and to the right, but these zeros are not. So what? How many is there? There's 3. See how easy you're getting this? This is great. Okay, now, what about this? What are you going to do with that 0? Is it 1? Is it 2? Is it 3? How many sig figs are there?
3.
I got a vote for 3. Anybody else?
Trace.
Okay, another vote for 3. You're right, I didn't fool you, because is this 0 to the right and to the right? Yes. So it would be 3. See, it could have come out to be 24.1, or it could have been 23.9, but when somebody measured it, it just happened to come out exactly to 24.0. So that means it counts as being significant. Okay, what is this one? Here's your final test.
6.
Okay, because this one's significant because it's in between non-zero numbers, so is this one. So 1, 2, 3, 4, 5, 6. 6 is correct. That is very, very good. All right, I think we're going to go ahead and stop there. Thanks for entertaining our video here, or watching our video. Would you just show the class one more time? Everybody wave. Excellent class. Cody, be a little more excited than that, please.
I'm being Mr. Rogers.
Oh, okay, that's right. Okay, cut.